Thank you very much, Neil. Good afternoon. A big thank you to Ken and Rosie and everyone for inviting me from the east side of the country to come and participate. I so much loved the Wave 2011 meeting. That was a bit of a revolution for me, and I'm so delighted to see a lot of faces here from that meeting. And indeed, I'm looking forward to the next one. So, Ken asked me to say a few words, but actually we're here this afternoon to hear a story from 4 wonderful companies, really groundbreaking technology. So first, and very briefly, I hope, I'm going to give you a little view from the other side of the fence. We are a user of the technologies that's being developed in this room. So Maple Leaf Foods is Canada's largest food processor with a number of brands, mainly in meat and bread and meals. And New York Bakery is actually the UK's leading bagel manufacturer. And we also have a biodiesel company which esterifies pig fat. So our challenge in the food industry is that our world is changing. And I'm sorry I'm losing my voice. I always do at conferences, so I'm glad you've got this thing. Chronic disease is becoming endemic. Cardiovascular disease, obesity, diabetes, cancer, the neurodegenerative disorders. And with that has come the realization that diet, to a very great extent, governs health. And we need to do something about the food that we're eating, and particularly in the aging population that I'm rapidly becoming a member of. And we've all heard the story on food safety. We know about sustainability, that's the atmosphere as well as the ground. And farming systems are becoming broken. Wheat producers can't afford to grow wheat anymore. They wish it was GM, but it isn't. We are mining the soil and not putting things back. From one crop to the next, indeed one load to the next, we can't make consistent bread. We are losing the quality of our agricultural raw materials. So what are we going to do about it? At Maple Leaf in 2008, which was the year that we had our listeriosis tragedy, we built this innovation center for $12 million in Ontario. And here are some of the products coming out of that today. There's a trend to be natural, to be gluten-free, get rid of allergies, convenience, resealable packaging, meals which are balanced and healthy. And on the bakery side, here you have natural tortellini from Olivieri. You have sauces in those 4 at the top. You have whole grain, very healthy bakery products. Now, I believe that it takes about 10,000 years for a bread packet to degrade in a landfill. So what we don't have is biodegradable packaging. We don't have tamper-evident resealable packaging either. So you can see a wish list is coming along. And nor, for that matter, in Canada are we competitive with the United States. And so last year we opened this $100 million bakery plant in Ontario, close to the transport infrastructure, and we're just building another $400 million plant for meats. We know what we need in the short term. We need something which will kill bacteria once the package has been sealed. The problem is anything that comes out the oven is sterile. By the time you seal it in a package, it's got contaminated. There is no technology to do that, so please, yes please. Sodium reduction, longer shelf life because of the geography, because you have to transport things so far. Biodegradable packaging, the public seems to want free from. It's so-called clean label. They don't want to know that the animals have had antibiotics, gluten-free, free from those kinds of things, but they do want it to be healthy, so naturally fortified. So what we need in the food industry today is a way to help people make healthy choices, to balance their diet. So we've been dreaming. We've been dreaming, for example, that we can put that information onto a QR code, which you can scan with your smartphone, and on your wrist, instead of a watch, is a smart monitor which is reading your blood metabolites, your metabolome, which we heard about, in real time, and transmitting it to your smartphone, which has also received the information about what you think you're going to eat for dinner, except that you're not going to eat it because you have too much cholesterol in your blood. So you go away and you scan a couple of dear old cabbages, and that's okay. They're approved. Now, I have a concern, and the concern has grown since I came into this room at 9 o'clock this morning. And that is, how do we find the technology that we need? Okay, today I'm fortunate. I'm here. I've got a vague idea what I need, and I hadn't got a clue what you were going to say. So I like to see things in two dimensions, and I can write a wish list, which is actually 100 items long across the top of that, on what I need. And there's technologies which I'm sure is 100 long, if not 1,000 long. So it works like this. We were looking for a way to make the cheese flavor stronger in pasta. So we knew we needed that, so we want to find something on that column which will do that. And sure enough, we found a company that can encapsulate flavors and cosmetics in pollen spores. So we get a match. So, you know, what's a formal process for doing that? I don't know. At the moment it's ad hoc. ACAMP has the vision to organize this. But unless we find a way to do this, we're not going to get the technology to where it's actually going to make a difference for Canada. So we found this company, Sporomex, and here are the spores. They're naturally occurring, they're all natural. That's the outside of the spore, and that's a section through the spore. There are nanotubules in that. You plug the nanotubules with something like gelatin, which melts or disintegrates in response to temperature or pH. So encapsulation. Now going on dreaming, what about the magic kitchen? The kitchen is somewhere where we could really apply some of this technology. What if I could embed in the QR code cooking instructions, exact cooking instructions. So you read that with your smartphone, and you decide you're in your car but not moving, and you call your oven, and you tell your oven what time you want dinner to be ready. Oops, I've gone the wrong way. I knew I would do that. I got excited. That's a very big mistake. And what happens is that your oven reads the QR code and transmits to the Maple Leaf server over there. The Maple Leaf server knows exactly what the fat content, weight, and everything of that item is. It sends a message and it cooks it to perfection. So how about that? Where's the technology, please? We're waiting. So finally, in my little introduction, because my background is actually a PhD in animal genetics, and I loved the metabolomics and everything this morning. For me, the big one here, the really big one, is where nanotechnology meets DNA, and they talk to each other. In other words, you get control of genes using other technology. And so it works like this. This is a chromosome with 4 protein genes and a promoter gene, which is a switch, which switches the protein genes on. So your nanotech talks to this promoter gene and switches it on, and that causes the proteins to be read off. Without GM, it's not genetic modification, you can switch genes on or off. So, for example, here in Alberta, you have a drought, you switch the genes for drought tolerance on, whatever, you know, the genes to deal with wetness, the genes to switch off certain aspects of gluten, to give consistent baking quality. I mean, wow, and make things healthy. So for me, coming from a background of biology and seeing what you're doing, this is the area that would get me really excited. And I think I got a flavor of some of that going on today. So finally, my little summary: if I was working in micro nanotechnology and looking at the food industry, these are the areas which I think are hot, which is food and health go digital, connect them, smart, safe packaging, food safety, supply chain efficiency, big country, we need to be efficient, traceability, things like that, process control, why has my bread got holes in it? And I think microencapsulation, although I'm not sure what the public thinks about microencapsulation. I mean, is it natural or unnatural? Are they going to like it? Or are they not? But it's certainly a delivery mechanism for things that can be nutritious. So, as I'm the chair, I'm not sure that I'm really going to be democratic and ask for a question. Well, I might. Just one question. Oh, there is one.
Just explain, please, what you mean by natural. Because in different countries, it means different things, different regions. It means different things. Natural is not organic. Could you just explain natural?
No, I can't explain. And the problem is, nor can anybody, because there is actually no clear definition. There is an accepted use by CFIA at the moment. You may have seen that there's been a number of lawsuits in the US on people using natural for things that transpire not to be natural. I can tell you what natural does not mean. It does not mean that you can find it in the forest. It means that rather little processing has been done to that. But there's obviously transformation. Give you an example, is cooking natural or not? You know, I haven't found any cooked pigs in the forest or anything like that. So the food industry badly needs that to be resolved, because that's going to drive a whole section of what you see on the supermarket shelf. So at that point, I think I'd like to begin introducing the four companies who are all extreme high achievers. And the first group is led by Dr. Sylvia Rebenlard and Brian Shaw. Is Brian here as well? Hi, Brian. They're from Hydroqual Laboratories in Calgary. They are indeed world experts on environmental regulations. They're both the University of Alberta graduates, which is very proper in this room. I'm probably the only one who isn't. And over to you. You have 12 lovely minutes.